Okay. 268 seconds. $50. How much is it? There is a lot of difference. Almost 3050. Welcome to my second video on Analytica TV. In this video we are going to make a 10 million Monte Carlo simulation in Quantlib C++ versus Quantlib Python distribution. First of all, it's not a fair comparison because C++ use parallel computing, but Python distributions obviously is more user-friendly with Jupyter notebooks. Python only use one vCPU. That means that if you use a server like me on this benchmark, you can waste money if you expect to use all the cores of the server. For real-time applications, C++ is a clearly wins. And finally, last but not least, I'm going to show you my project, signal.com. This is an open source Python library written in Rust. It's a quantitative engines that want to take advantage of parallelisms. So let's get to the dashboard. We are on Amazon Web Service. This is the Medium post. You are going to find all the steps and finally the benchmarks we get. We are going to set up an instance like the last video. Launch instance, a name, Quantlib 10 million. The benchmark will be with a European option simulation. It's an Ubuntu server 22.4 works. The type of instance T3 ./. Clearly we can check a vCPU, 64 GB of memory. The key, I have a existing group. In this group we have to open the 88 port. I see. Let's check this later. 10 launch instance or terminal instance. This is the IP. Yes. Okay. Clear. Okay. Just copy. Just copy. Copy and compile. We are on the home directory. We're inside. Gather world. CMake. With these directories, we're enable parallelism. Okay. Make. Okay, this is going to take a while, like our last video. Okay, finally. Let's clear this. Let's check the version. Everything. It's okay. Yeah, it's okay. But we have to export the number of cores of threads. Copy. Yeah. In this instance, I have A. Probably you can have 4 or 16. With this script, I'm going to test if all the threads are available. Okay. Okay, and compile. It's everything run good. Okay, this is wrong. Let's make a screenshot. Yeah. Okay. The second step, we're going to run Jupyter notebooks in this instance. Okay. Let's install everything. Okay, we are in the home directory. Apparently, we need this. So we need this. Okay. Python 3. Okay. We are inside the Python environment. Installed some libraries, including Quantlib. This is our IP. Okay, it's important because we're going to run Jupyter. The security port in the port 8080 has to be available. Let's check. Security. You know, the port 22808888 is open. It's important. Okay. Okay, this is the direction. This is the direction with the talk. We put in a browser, but with the IP. No? And we have running a Jupyter notebook server in the instance. Okay? Another terminal. SSH. Okay, we're running the benchmark. Okay, we can erase this and this. It's clean. Yeah. This is a Monte Carlo simulation, a simple simulation. 10 million Monte Carlo paths with parallelism. Okay, with pragma OMP. We can copy this and what's the name? Million. 10 million. Okay. We can paste the parameters, and after the simulation we're going to get an output with the answer at the runtime, with the calculation and the runtime. Okay. So compile this flag is important. FOPMP. Well, whatever. 10 million. Okay, we got it. 10 million. Yes. What's the time? Less than 1 second. Okay, and the software use the 8 threads of the server. That's good. A screenshot. Okay, and the similar tests, but in Python. Okay, it's unfair because launch import Quantlib as GT. This because it only use one thread, but it's very necessary, this exercise, to got the whole picture. Okay, and finally we're going to run this. Let's check the time. Okay, it's syncing. finally we have to write the benchmark. Edit history. How many seconds? How many seconds? Get 765. Okay. Oh. It's still thinking. I did many times this benchmark. It's almost 263.70 seconds. Almost 4 minutes. 4 minutes, 5 minutes. I'm going to update this. These screenshots. I left the comments in the box. Please subscribe. And the next video we are going to cover some Quantlib exercise and other technologies and software about quantitative analysis. I want to cover Numerai or some other sites where we can find championships about quantitative championships. Will be very interesting. It's still thinking. Okay. 268 seconds. $50. How much is it? There is a lot of difference. Almost 3050 times the C++ distribution. Okay, that's all for today. See you in the next video.